you and I may not share some commitments, and there may be some things that we're just going to never come to agreement on. Maybe you're a Platonist and I'm a fictionist, and we just can't come to agreement on that. But what we can do is try our best to individually to make our own belief sets hang together. And I take it that a lot of what I'm doing when I'm doing philosophy is trying to work out, get my beliefs in order.
Welcome everyone to today's interview, where I'm very pleased to welcome Professor Mary Leng. She is Professor of Philosophy at York University, and her work is focused primarily on the philosophy of mathematics and science, and although she's worked a bit on other topics as well. Her book is Mathematics and Reality, and she's published a variety of articles on the aforementioned topics and more. Feel free to add anything, but with that, welcome and thanks so much for being here, Professor Leng.
Thank you so much for inviting me. It's really nice to be here, and I've got nothing to add. That was a very nice introduction.
Fair enough. All right. So I kind of wanted to just kind of dive in head first here on the philosophy of mathematics. And so, as I understand, you call yourself a mathematical fictionalist. Just for the purposes of the audience, you kind of explain what your view here amounts to in broad brushstrokes, and like maybe contrast it with some of the other kind of alternative views like platonism and structuralism.
Sure. Okay. So when we do maths, we say lots of things that seem to be talking about objects, right? So I'll say 2 is the unique even prime number. There are infinitely many prime numbers. There's a function that represents the mass of an object as a multiple of real numbers. So we talk about these objects, numbers, both in doing ordinary pure maths and also when we use maths in the world as well to do physics, for example. And all the time we're speaking as if there are objects. There is a real number, there is a function, there's a unique even prime number, and so on. So on the face of it, those claims are committed to the existence of a kind of object, right? So the number 2 or the infinitely many primes or the real numbers or functions and so on. And that raises a difficulty, I think, because when we start thinking about what maths is about, if we take it at face value and take it as a body of truths about these objects, that raises the question, well, what kind of things could they be? What sort of objects are they and how can we come to know them? So philosophers don't have a really good answer to that question. So typically when we talk about what kinds of objects mathematical objects are, we do so negatively. So we say, look, they're not physical things, right? The number 2 isn't something you find in a physical location. It's not something you bump into in the street. They're not mental things. You might initially you might think, okay, well, maybe the number 2 is an idea in my head, right? But that doesn't quite seem right. There's many reasons why we might have problems with that. One is that we all have different ideas in different heads, and there's meant to be a unique number 2, so that's a problem. But also, mathematics seems to talk about the existence of many more objects than could be held in any of our heads altogether, right? So the infinitely many real numbers, sets, and so on. So mental objects doesn't work very well for that kind of picture. So then it doesn't look like they're mental either. Maybe they could be linguistic creatures of our language. We might think, okay, well, when we introduce mathematical terminology, maybe somehow the objects are to do with the words or something, but again, that doesn't really seem to work. And in fact, any account that makes numbers somehow our creation seems to have the difficulty of explaining how it could be that we want to say that even if there were no people, 2 + 2 would still be 4, for example. So none of those accounts of what mathematical objects could be seem to work very well. So typically philosophers think of when they characterize mathematical objects, they do it negatively. They say they're not spatiotemporal, they're not mental, they're not social constructs, they're not linguistic, they're not causal entities. And that negative characterization, we give it a label and we say, well, that makes them abstract, and abstract just means none of the above. Right? Now, if you start from that point and say, okay, well, mathematical objects are these abstract things, and abstract we understand in this negatively characterized way, it then becomes very difficult to say anything positive about how we can come to know things about such objects, right? So if I had said that they were physical or spatiotemporally located or causal, then I'd be able to use my story of how I interact with the causal world to give an account of how I come to know about them, or if they were our constructions, or if they were mental, we'd be able to have a story about how we can know them. But because they're negatively characterized, it's very hard to say anything positive about how we could come to know mathematical objects. And I take that worry very seriously. So I take it that if mathematical objects were to exist, they couldn't be any of the normal kinds of things. They'd have to fall into this category of being abstract. And I take it seriously that it's very difficult to say how we could come to know things about abstract objects. And yet mathematical knowledge is somehow meant to be amongst the most certain kind of knowledge we have, right? So it's kind of odd that if we have this account of mathematical objects, it makes knowledge of mathematical truths seem problematic, and yet mathematical knowledge, that 2 + 2 = 4 is one of the most clear examples of something that we might want to say is certain knowledge. So because of all those reasons, I think we need to rethink what maths is about. And as a fictionalist, I say, okay, well, it's true that if we took mathematics literally and seriously, it would be a body of truths about these abstract objects. If we did that, it'd be hard to explain how we can know mathematics at all, or what we're doing when we're doing mathematics, and how we interact with these things and so on. So my solution is to say, well, let's not take mathematics seriously in that sense. Let's not take mathematical language as seriously as we might. And instead I say, okay, well, let's think of ourselves as not, when we're doing mathematics, not speaking truly of objects, but speaking as if there are objects, and saying what would be the case if there were objects of this sort. And that's what gets us close to fiction, because on my picture, the number 2 is really something like Sherlock Holmes, right? So in the Holmes stories, we speak as if there's this person, Holmes, who has all of these various properties. There's no big mystery as to how we know things about Sherlock Holmes. The things that are true of Sherlock Holmes are true in the stories about Sherlock Holmes, just because that's what Conan Doyle told us. That's what's in the stories. That's what they were written down. So I want to say we can think similarly about mathematical objects. So instead of saying that it's true that there's a number 2 and it's the only even prime number and so on, I want to say, well, according to the story of arithmetic, there is this object 2 that's an even prime number, and so on and so on and so on. And it's no mystery that we can know that that's true according to the story, because we've laid out what the story is. We've written down the axioms, and it follows from that and so on, that 2 is the only even prime number. So moving from a starting point that says mathematics is a body of truths about some strange kind of object that we can somehow come to know about, to saying mathematics is made up of something like stories that we tell about what would be the case if there were objects of a particular sort, helps, I think, to get around some of those difficulties about how could we possibly know those things. We're not terribly worried about how do we know things about Sherlock Holmes. And I think the same should be said of at least basic truths about the number 2. They're truths according to the story of maths.
Very good. I love this great introduction. So many things I want to get into there. First, I just had a general question about like this abstract view in Platonism, and it's like it's long kind of been a concern of mine that the negative characterization is like fine as far as it goes, but we might worry that it's really still too imprecise, in that there's potentially a lot of different things that could satisfy those descriptions.
Yeah.
And it's not really, we haven't, and if you say something more about, well, okay, but they satisfy these mathematical relations and something, we might still wonder what exactly that's supposed to be. We might want more of a positive characterization.
Yeah. Right. Yeah.
How much of that was a worry to you? Yeah.
Yeah. So I think numbers and mathematical objects aren't the only things that get counted as abstract, right? So we also think, maybe there's these things called properties or universals that are abstract things, and
propositions and so on. Yeah.
Yes. So even if we were to say mathematical objects are abstract objects, that wouldn't be the end of the story about what mathematical objects are. They'd have to be abstract objects of a particular sort. I guess I'm not as concerned about that worry, because as you say, our mathematical theories tell us a fair bit more about what would have to be true of these objects for them to count as mathematical objects, right? So they'd have to satisfy the axioms of so the numbers would have to satisfy the axioms of number theory and so on, right? Although that kind of it does bring in another interesting problem with Platonism, which is the kind of embarrassment of riches. So even if you talk within the realm of the abstract, and you say, okay, well, the numbers are going to be abstract objects that satisfy the axioms for number theory, it turns out there's just multiple different ways of satisfying those axioms. So, for example, if I start with set theory as a kind of base theory in mathematics, I can find multiple different systems of sets, all of which would do the job of the natural numbers. So this is a problem. So I should have mentioned, really, when we talked about the knowledge problem for mathematical objects, that was a problem that was highlighted by Paul Benacerraf, and his other problem is the one I'm just going to mention now, is this problem of multiple reduction. So Benacerraf presented two major problems for Platonism, and this second problem is the thought that even if you've said all that you think there possibly is to say about the natural numbers, that's not going to pin down precisely which objects those things are, because there seems to be it both seems to be the case that there's nothing more to the numbers than is characterized in number theory, so then what follows from the axioms of number theory, and it's also the case that there are multiple systems of objects that we can interpret those axioms as being true of if we interpret the primitive terminology in one way or another way. So the axioms don't decide between different ways of interpreting those claims. So that's another kind of problem with the Platonist picture of numbers as objects, is our mathematical theories just don't seem to have enough information to pin down which objects those things could be. The fictionalist kind of has it easier again, I think, because they aren't saying that there are objects of this sort. They're saying, look, when we're doing number theory, we're imagining what would have to be the case were there objects of this sort, and it's open to that picture for there to be multiple different systems of objects that would satisfy those axioms, or no objects that satisfy those axioms. All of those things are allowed in that picture. So standard Platonism certainly has a problem there with pinning down exactly what we're meant to be talking about.
Right. Yeah, I was going to bring up the Benacerraf identification problem. I was going to bring up. I might still bring that up later, but
sure.
Because it might be relevant to just on the fictionalism there. Would you say people sometimes make this distinction between like revolutionary versus hermeneutic fictionalism? Where would you say you fall there? Are you saying that the discourse already functions as a sort of fiction, or are you like kind of suggesting that it'd be better if it did, so to speak?
So I'm on the side of the revolutionaries generally, and certainly in this case. So I think it's probably unclear for many people for many maths users, whether they mean to be speaking literally of objects, or whether they take themselves to be working out what would be true if there were things of this sort. But so I'm not sure if there's an answer. So for people who haven't come across the hermeneutic revolutionary divide, I guess the way I see it is a hermeneutic fictionalist looks at people speaking, looks at users of a discourse and says, well, it looks like they're saying things that they believe to be true, but actually they don't believe those things to be true. They're doing something a bit different. Maybe they're participating in the make-believe, maybe they're storytelling or whatever. So the hermeneutic fictionist would look at mathematicians who are saying things like, they're infinitely many prime numbers and so on, and say, well, it might look like they're committing to the existence of objects, but actually when they're saying those kind of things, they're only making a move in a kind of make-believe game, or they're only working out what would be true if these axioms were true, with the kind of disavowing preface at the beginning. Whereas the revolutionary fictionist says, well, actually, yeah, for all we know, mathematicians, when they're using mathematics, do take themselves to be speaking literally of objects, but they shouldn't. What they should do instead is say all the same things, but say it against the knowing backdrop of a preface that says, "Oh, in what follows, I'm not endorsing any of this. I'm just working out what would be the case if my axioms were true." So that's the revolutionary hermeneutic divide. Insofar as the hermeneutic picture makes sense, there has to be some kind of fact of the matter about what mathematicians as a group typically mean to be doing when they're doing mathematics. And I'm not sure that there is a clear fact of the matter about that. I think that there might be differences between different mathematicians. There might be people might just not have thought about it, or know whether they want to be saying these things in a committal way or not. I think, on the other hand, the revolutionary picture makes sense regardless of whether there's a fact of the matter about what working mathematicians do typically mean by what they say, because the revolutionary fictionist can say, well, whatever attitude you in fact take, here's a recommended attitude for you. Your attitude should be to say, well, I'm not endorsing any of this talk. I'm just working out what would follow from my mathematical axioms. So I prefer the revolutionary picture for that reason.
Yeah. Okay. Good. Yeah. I like that kind of attitude there, because I was going to bring up this related worry that a fair amount of views in philosophy of mathematics, and you see this elsewhere, like in metaethics and other cases, the views make certain assumptions about the semantics of the relevant discourse. Mm-hmm. You might think of fictionalism as like a kind of error theory in metaethics, but it's requiring that the relevant discourse is like cognitive, and it's making assertions that they're object or properties of a certain sort. But we might challenge or doubt these assumptions.
Yeah, absolutely.
And it may not want your theory, mathematical or metaethical or whatever, to really turn so much on the empirical semantic facts. Yeah, you kind of answered this about it, but maybe if you want to.
Yeah, no, I'll take that. I think that's right. It's desirable not to be hostage to fortune now in terms of working out what certainly if the semantic facts about what people typically mean by what they're saying. So I think the revolutionary. Well, I guess there might be some question mark over whether it should be labelled revolutionary if in fact everybody turns out to be fictionist anyhow. But the picture that says what I'm doing is prescribing rather than describing your activity, what your engagement with this activity should be, I think is preferable. In fact, I mean, I have flirted with the idea that the fictionalist account is descriptive of many actual mathematicians' engagements with mathematics, and not just prescriptive. But I don't want to commit myself to that. But there are features of mathematicians' engagement with mathematics that make it look like, even to them, they're not really working they're not really acting as a true believer in objects would act, right? So the philosopher Frege was a true Platonist. He was a true believer in mathematical objects. For that reason, he thought, okay, I'm going to tell you what the number 2 is, and I have to give you a definition of the number 2 that makes clear that the number 2 is different from Julius Caesar. Right? And he took that question very seriously and thought, well, it's really important when I'm giving an account of what numbers are to make sure that my definition of numbers tells me exactly what object the number 2 is and rules out it being Julius Caesar or any other object, right? But mathematicians, when they're talking about numbers, they are very relaxed about identity conditions. So aside from that kind of Benacerraf multiple reductions worry we had earlier, mathematicians working within set theory, where you can pick one, you can pick a reduction of numbers to particular kind of sets, natural numbers to a particular kind of sets, and then you introduce the integers and the rational numbers and the real numbers as constructions out of those, as constructions of sets upon sets upon sets. If you do that, the natural number 2 and the real number 2 and the integer 2 and the rational number 2, all of those number 2s are different sets, right? In that picture. But no mathematician worries when they're talking about the number 2 whether they're talking about this set or this set or this set or this set. And so to me, it's that's kind of indicative. I still put another syllable in it. It indicates that they're really not engaging with these things thinking I'm talking about particular objects here. And anything will do that will satisfy the axioms, and they're not specific. They're not particularly bothered about what it is they're talking about, or whether they're talking about this thing or another thing, and so on, which you'd expect if they were true Platonists. But as I said, I kind of flirt with that idea, but I'm not endorsing a hermeneutic picture, because I think there just is enough variation in mathematical attitudes to mathematics that it's really hard to know. There probably are some Platonist mathematicians, and there probably are some nominalist ones, and they all seem to manage to do maths.
Yeah, good. I mean, I definitely am open to the possibility that there's a lot of maybe variability and even indeterminacy here, maybe on what people are actually committing to. But the thing you said about Frege reminded me of like when I once had a lecture on Frege, and the philosopher and the professor opened the lecture by saying something like, asking us like, well, what is the number 1? And I don't know, like, it wasn't that I was trying to like, oh, maybe it's this or this or this. The question almost didn't make sense to me. It's like, it's like when maybe this is not a common sentiment, but for me, it's like, I almost wasn't like sure that my discourse involving that term was such that question really made sense.
Yeah.
Like I was saying, there's
jumping ahead on day one of your Frege lecture to kind of Benacerraf's worries about it, right? Especially the worries of what numbers could not be, because that's precisely his point. The discourse just doesn't give you anything like an answer to that question, and neither should it, right? It's good enough for maths to have these ways of talking without pinning down precisely which object that is. Now, for Benacerraf seems to take that in a kind of structuralist direction, to say it's the structures that matter really. But I think it can be equally well taken in a fictionalist direction, to say, well, we don't need to pin down who is Sherlock Holmes, right? And whether the Holmes from this story is the same as the Holmes from this story and this other story and so on. It doesn't really matter. We can stipulate those kinds of things. All there is to Holmes is what follows from the stories, if you like.
Yeah, I don't think I really had the Benacerraf worry at the time. It was maybe something more like I was suspicious that the discourse was even meant to be like ontologically committing in the first place.
Yeah, I think a lot of people do. I sort of thinking back to when I first encountered worries about mathematical objects. It was back when I was an A-level student, and I was starting to do the kind of more abstract bits of mathematics. So we started doing vector spaces, and you get given the axioms for vector spaces, but you're not really told what are these things, right? And I said to my maths teacher, well, what are these things? I've never seen one of these things before. And I actually had two maths teachers at the time. And one of them, when I asked that question, he said, well, here's the axioms. What's your problem? The axioms tell you what they are. And the other one had done a maths and philosophy degree. So he was like, well, sure, there might be a question there. But if you're worried about vector spaces, you should be worried about numbers. And my initial thought that was, well, I'm not worried about what the number 2 is, right? And I think in part that initial thought was kind of born of just familiarity, right? We write the number 2 all the time. We used to, from childhood, the kind of Sesame Street walking numerals, right? Makes you think, okay, well, I know what number 2 is. It's a thing like this. But actually, once you kind of step away from the familiarity and start thinking, well, what kind of thing is it? The questions start to get some kind of bite, I think. But I think my initial thought was, well, a number's a little bit like a letter, right? The number 2 is a little bit like the letter A, and I'm not worried about the existence of the letter A, so why should I be worried about the existence of the number 2? And I think that's quite a natural thought, right? To think of numbers and letters as kind of a similar thing. But I think my mistake in having that initial thought was to mistake the numerals for their referent, right? So there's lots of, I can write down lots of number 2s by writing down lots of numerals here and there and everywhere. And they, all those numerals of the same type, just as I have different letter types of the letter A. And then we might think, okay, well, just as there is the type A, there is the number 2, which is the type that all of these tokens have in common. So, that doesn't give us any kind of strange new object. It's just a commonality between these different ways of writing things down and so on. But when we do maths with the numbers, we seem to be saying lots of things that are not true of the numeral type, if you like. So that there are infinitely many numbers, for example, is not a fact about the numeral types. The properties of 2 are not properties of the numeral type. That it's the only even prime number that's not a property of that numeral type. So there's a whole bunch of questions about the object that don't seem to be akin to those questions about letters, if you like. So that was a bit of a digression, but I was just trying to think back to why I didn't initially think there was a problem there, and what convinced me that there was something different going on with numbers.
So just a couple more things on this. I know one thing I found, I don't know, important in my thinking about these topics is the distinction we might make between like a thicker or thinner discourse. Like that might be difficult to pin down exactly, but like the way I'm thinking about it, roughly a relatively thicker discourse will involve more like substantive commitments, especially ontological commitments. And so I think like, the statement there is an even prime number or whatever may be ambiguous between a thicker and thinner reading. And, accordingly, different accounts in the philosophy of mathematics may be correct, depending on which reading we give, I mean, what do you think about this? And
yeah, so that kind of thick, thin kind of distinction comes up in various different places and doing slightly different things. So Jody Azuni talks about it in terms of our ways of accessing kinds of objects. So physical objects are objects that he thinks we have a kind of thick epistemic access to. They're things that we can track through the world and so on. Whereas He actually puts numbers on not just as thin, but ultra thin, in terms of the ways we can access them. Our access to them is not through a kind of causal interaction with independent objects. But the other place where that distinction comes up, that terminology thing comes up, which I think might be closer to what you're getting at, is in Øystein Lindeboe's picture of mathematical objects as thin objects, and I think so. There, Lindeboe says so. Azuni's distinction is, I guess, epistemic. It's about all kinds of access, whereas Lindeboe's is explicitly metaphysical, and as I understand the distinction, for Lindeboe, thin objects are objects whose existence doesn't require much of the world around them. So they don't depend on much for them to come into existence. So my hand's existence, that depends on there being physical stuff with particular physical arrangement and so on. But the number two's existence for Lindeboe requires only that there are pairs of things in the world, effectively, and equinumerosity relations between them. So he says, he uses back to Frege again, Hume's principle, the abstraction principle that says the number of F's is the number of G's if only if the F's and G's are equinumerous. Say, well, look, whenever you have a pair of things and another pair of things, right, those are equinumerous with each other. That's enough for there to be something that we call the number of fingers that I'm holding up. So that's enough for the number two to exist. So there, Lindeboe's idea is that these objects exist, but their existence depends on very little. It requires very little in the world, right? There doesn't have to be on top of my fingers. There doesn't have to be an extra physical object in virtue of which the number two exists. The number two's existence just is a matter of there being pairs of things and so on. And I've argued that kind of picture of mathematical objects as really existing, but having this kind of thin existence, is close enough to fictionalism for it really to be perhaps just a matter of taste about how we use the word exists, right? So if I stick with fictionalism and say, well, look, whenever I'm holding two fingers up, that doesn't mean that there literally is an object, the number two. I'm kind of using there is in a kind of thick, heavyweight way, right? And I'm saying, I don't believe that. But Øystein, when he says, well, look, when there are two fingers, then there is a number two. He's not using there is in a thick, heavyweight way. So it becomes a little bit difficult to see what the issue is between us there. And I think that's probably right. I think there isn't a massive metaphysical difference between something like a thin objects picture of the numbers and a fictionalist view. What that does mean, though, is those thin versions of mathematical realism, I think, are going to inherit all this problems that people batter fictionalists with. So people say, well, all very well to try and deny the existence of objects and get away without having these hefty metaphysical commitments. But if you're going to do that, you're going to have a problem explaining how maths is applicable and understanding the explanatory role of mathematics in science and so on. And I try and give a story about how a fictionist can do all those things. But I also think a picture of mathematical objects as existing, but existing in only this very lightweight, thin way, is going to have all those kinds of same challenges to it that a fictionist has. So I kind of agree that there might not be much at issue between those two kinds of pictures of mathematics, but where I would press someone who wants to take a thin objects view and say, well, yeah, sure, I'm a Platonist about maths, right? I believe in these objects, they exist, and that's not a problem. My challenge to them is to say, okay, well, if just calling yourself a Platonist doesn't get you the alleged advantages of Platonism if the existence of the objects that you're committing to is so lightweight, right? So you need to show why you don't avoid the problems that people think a fictionalist is going to have.
That's a good point. Yeah, I guess maybe the view, this is sort of similar, but I think it's distinct, which is that it's not that the existence claims are asserting a sort of the inner existence of these objects, but it might be such that we're not even really, it's not really an ontological claim at all. Maybe like it could be that the way the claim functions and it's evaluated for truth and so on doesn't really even require that there's an object, thin or otherwise, there. It's like, I don't know, like I think about different claims we might make in normal discourse, like I don't know, there's a table, there's a tree, whatever. That's a pretty standard kind of robust existence claim. But when I say something like there's a dance or there's a Formula One race, I'm not sure that I'm doing something quite the same.
Right.
Maybe there's a claim that's evaluated for truth in a way that doesn't require, like there's this object there, thin or otherwise.
Right. So I mean, in a way, that's kind of grist to the thin objects picture, because I'll say, well, look, the conditions that make it appropriate to say there's a dance, or the existence of dances, depends only on more ground level things in the world, certain movements and social understandings and so on about what's happening when people move in a particular way. I think I'm perfectly happy to follow the kind of thin realist there and say, yeah, objects like dances, the truth condition of there is a dance doesn't require a special new kind of object. It is just dependent on these practices and so on, and some complicated story about what the conditions are, in virtue of which it's appropriate to say these kind of things. So I guess the question is, why do I resist that with there is a number, right? So I guess the worry is when I look at what's happening in the ballroom and say there's a dance or whatever, we can think of that as kind of just redescribing the very same things, right? So look at this phenomenon and say, okay, well, this is an instance of what we like to call a dance. It fits the criteria. But my worry with mathematical objects is when we say, if I put my fingers up like this and say, there is a number 2, right? Yeah, I do. In a way, I do want to say this is an instance of a pair, right? There are 2 things there, and so on. But we seem to be doing something more than redescribing what's going on in this vicinity when I say the number 2 exists. So I don't even want to say the number 2's there, right? Because it's not. It's meant to not be located anywhere. So it seems that those introductions of numbers on the basis of equinumerosity conditions, so on the basis of abstraction principles, they seem to be doing more than just, I guess, what Frege called recarving content, more than just redescribing the same things in different ways, right? I suppose one reason you might think that there's something fishy going on there is that actually Linnebo doesn't make this move, but the standard use of Hume's principle does, is that we allow we allow Hume's principle to be used impredicatively, right? So I can say these things are equinumerous to these things, so I can say therefore the number 2 exists, but then I can also talk about the equinumerosity of the numbers from 0 to 5 with the numbers from 6 to 10, and say that those things exist, and so we can allow the numbers to be back in the things that we were describing. I'm not explaining this very well. We can. So if we were simply redescribing the same things in different ways, we wouldn't think when we introduce the new objects and new ways of describing the old things that those new objects were there in the domain that we started with, right? We've done something new, and that issue, the fact that traditionally, when we use Hume's principle, we do think of the domain that we're starting with as including all the objects are, including all of these numbers, right? Suggests that we can't really think of it as just redescribing the old things. I shouldn't really have started that thought with Linnebo, though, because Linnebo doesn't allow for impredicative uses of Hume's principle, but he does allow for iterated uses. So what he says is that we can so maybe there's only finitely many objects in the physical world, right? And that's going to get us through his thin objects picture. That's going to get us all the numbers from 1 to n, right? Because the largest collection has only n things in, whatever that large number n is. But that's not going to get us all the numbers we need. But then once we've got the numbers from 1 to n, we can add those into our original domain. So we've got all the physical things there were. Then we've got all the numbers from 1 to n as well. And then we can get more numbers out by counting those things. And then you can do that again and again and again and again and again. And then you've got all the numbers you want. So on Linnebo's picture, he doesn't take the numbers to be there in the first place, but he does think once we've described the physical objects that are in the world and got out of that the thin existence of the numbers from 1 to n, we can add those things into our base level and count those things and then get more numbers and more numbers and more numbers. And it's that step, I guess, that really seems to me to be something a bit different from just redescribing the things that were there already, which is why I think it's different from dances and things like that, right? Yeah, sorry, that I'm not sure if that made much sense, but
no, it's good. I mean, it's tricky. I mean, I feel like a lot of this is going to turn on difficult issues in like semantics and reference and ontological commitment and so on. And
yeah,
I know. I wonder how, do you think a lot of progress might be made or like resolution might be made if we spent more time focusing on these underlying issues, or do you think that would be more helpful?
I don't know. So in some ways, it feels like philosophers and maths have spent lots of time focusing on these things, but still not made progress. But yeah. So I think that there are some nice examples where looking a little bit more carefully about how we might be using mathematical language has helped us to sort of loosen the grip of a certain kind of picture. So there's a nice example that again comes from structuralism rather than fictionalism, really, but this is an example of Stuart Shapiro's, where he points out that actually, despite our often talking as if we've identified a particular thing that we're talking about, actually we're doing no such thing. And he gives the example of the square root of -1. Right? So I've just used a definite description there, right? So it looks like I've picked out one and only one thing, the square root of -1. But of course, there's two square roots of -1, the positive one and the negative one, right? And so there's these two objects. If you're a Platonist, there's these two objects in the mathematical realm that we could be talking about when we say the positive square root of -1. I could be talking about this one, or I could be talking about this one, right? But it turns out they're completely interchangeable. So if I decide this is the positive square root of -1 and this is the negative one, I can be talking about this one, and everything I say about the positive square root of 1 is true of this. Everything I say about the negative square root of 1 is true of that one. But I could switch them around. I could equally well have labelled this one the negative one and this one the positive one, right? And it wouldn't have made any difference. And this gets pressed as a problem for structuralism, because structuralists say, well, look, mathematics is just about positions in structures, and if there are positions in structures that can't be distinguished from each other, then it looks like there might be a difficulty for that kind of picture. And it certainly looks like it might be difficult for the idea that we can refer uniquely to a position in a structure, right? Can I refer to this position as opposed to that one, given that they're interchangeable? And Shapiro says, well, look, we're kind of misled by language here, by the fact that we're using a definite description into thinking that we have somehow succeeded in picking out one and only one thing to talk about. But in fact, if you look more closely at how we use definite descriptions or use apparently referring terms in ordinary language all the time, actually we very often do so without really picking out a specific thing. So if I say, let me find a non-maths example. So I might say I'm talking
like the
about
hypothetical cases or the fictional ones.
Yeah. So I'm trying to think of a non-maths and a non-fictional case, a real case, but I don't know. There's let's take, I don't know, in the crowd at Glastonbury the other week, right? There's thousands and thousands of people, and we might say, okay, well, take a guy who is in the front row at watching. Now I have to remember who was watching Lizzo, right? There's a guy in the front row there. There's actually lots of guys in the front row, but I might say, oh, well, call him Fred. Now, Fred must have had a good time, and I could carry on reasoning about Fred and so on, right? In that kind of use, I've not really picked out a particular individual. I've just said, well, take one, doesn't matter, anyone. What I can imagine I've picked one, give him a name, a dummy name, and then I'll carry on talking about what things must have been like for that person in that. And that we do all the time, right? We say, take a person of this sort, let's call them this, let's carry on, and then we carry on saying about what would have to be true of them without actually having picked out a unique individual in the first place. And Shapiro said, well, he probably had better examples than me. I should have reminded myself of what he says here. But he says, look, actually a very similar thing is going on when we say take the square root of -1, right? Or we're kind of saying, pick a square root of -1, any one you like. And of course, we can't actually pick any particular one because we can't point directly at one or the other. So he says, pick a square root of -1. Let's call that one the positive square root of -1, and on we go. Right, and then we speak as if we've identified something when we haven't actually identified a unique object at all. I think that kind of little look at the way language can mislead is actually quite helpful in dissolving some kind of worries, right? So we had this worry that it seems like we're talking about a unique object, but nothing in our practice could determine that we were pointing at this square root of -1 rather than that one, or this position rather than that position. Then looking at how we use, how we do often speak indefinitely of objects without specifying which ones they are, helps to kind of dissolve that worry, right? Turned out we were never talking about a particular object. Well, that doesn't matter. It doesn't matter to the practice. All that matters is that we could have, there could have been one, or that we somehow imagine ourselves as picking one.
Right. I think one example you had from that paper was the chess piece example, like if there were 9 pawns or something.
Yeah, right. Yeah, that's one of Shapiro's examples. Thank you. Yeah. So yeah, I can't remember how he uses it now, but yeah.
If there were 9 white pawns, like, well, where, like, we could talk about.
So then we could say, pick one, and then that pawn, blah blah blah. But you can carry on talking about the pawn, but actually, you don't have to assume that there's a particular pawn that you've picked out, right? They're all indistinguishable from but yeah, we could say, oh, we'll take one, call it A, or whatever, call it pawn A, and carry on. So long as it's not already been put on the board and it's got a particular position, in which case it might matter which one you're talking about. But if you just got the chess pieces in a bag or something, right? Yeah. So that kind of thing is utterly ordinary in a way, right? And yet it helps to dissolve a kind of problem about uniqueness of reference. And I think that kind of thing also helps the fictionalist as well. So the fictionalist doesn't, as I said before, we don't have a massive problem about the uniqueness of reference, but one problem that gets pushed at us is, well, look, you say that there are no numbers, and yet mathematicians always talk about the number 2 and so on. Well, if we can talk about the square root of -1 without really talking about one or the other, so if uniqueness doesn't matter there, I want to say, well, actually, similarly in many of our mathematical contexts, it might be that the existence doesn't really matter, right? Whether there really is something that's the number 2 that you're talking about doesn't necessarily matter for you to be able to talk meaningfully as if there were one. So we could kind of say, well, look, I don't know if there's a number 2, but suppose there is, then it would follow from that various things would be the case. We might then think that if it was reasonable to understand mathematical discourse as having that kind of disavowing preface at the beginning, then, well, on the face of it, it looks like people are talking about unique and existing objects. Just to say uniqueness doesn't necessarily matter, their existence doesn't necessarily matter either. We just say, oh, well, this is what would be true of this kind of thing if there were one.
Right. Is a problem here sort of similar in a way to, I was thinking of harking back to earlier, like another application of the Benacerraf identification problem, just applied to I, sort of, it's kind of the same thing, right?
It is, yeah. So it's another iteration of that in a way, because structuralism was meant to avoid that problem by saying, well, look, the reason why we can't say which object the number 2 is because actually mathematical objects are positions in structures. So the number 2 just is the 2 position, and many different objects in different systems could occupy that position. So there could be many. So Shapiro makes a nice distinction between offices and office holders, right? So the number 2 office could have many different office holders in different systems of objects that are doing the jobs of the natural numbers. So the structuralism was meant to solve that problem, but the I and minus I issue kind of bit back because way the first problem is solved is by saying, well, look, the objects of mathematics are positions in structures, and that explains why many different things can occupy those positions. But if you have structures where the positions themselves are interchangeable, then you have the question of, well, how is the I position distinguished from the minus I position, given that they can be swapped around? And in a way, I mean, Shapiro himself didn't take that worry particularly seriously, because he says, well, look, the structure tells you that there are these two different positions, so that's all you need, right? But the further story about what's going on when we think of ourselves as talking about one of those positions as opposed to another one is meant to fill in some details there as to how it can be possible to talk about these positions if we can't really definitively pin down that one rather than that one.
Yeah. Just a quick question on structuralism, because I'm going to be talking to Michael Resnick in a few days, and he's been moving towards a kind of what he calls non-ontological structuralism. Mm-hmm. One of the key features of this, separating it from other forms of structuralism, is that it's just kind of silent on the existence of any mathematical objects. Although, I wonder what you think about that broadly, and it seems like we're getting closer and closer to something compatible with a kind of fictionalism.
Yeah, I do. So I do think that. So I have a paper called Algebraic Approaches to Mathematics, where I basically argue that fictionalism, modal structuralism, sort of anti-REM structuralism, the kind of Shapiro picture that Resnick is sometimes thought of as having, and also the kind of full-blooded Platonism of Mark Balaguer, all of those positions are basically skirting around the same. They're kind of, in a way, variations on a theme, in that they all face similar problems and have to have similar ways of solving them. So I do share the thought that actually some of these things might be closer together than we thought. And in particular, what they have in common is they all start with this kind of algebraic picture. So that's terminology that goes back to Hellman, which says that effectively what characterizes our mathematical objects are mathematical axioms, effectively. So long as you have a kind of consistent or coherent axiomatization, then that's enough to say that your mathematical theory is good enough, right? To count as a mathematical theory. I mean, it might not be interesting or whatever, but metaphysically, it's fine. Now, all of those views do that in a slightly different way. So the kind of Platonist versions say that if you have a coherent axiom system, then the objects that you're talking about exist, or the structures that you're talking about exist. And the non-Platonist ones say, well, no, coherence doesn't give you the existence of objects, but it does give you the content to your mathematical theories, if you like. So you can say, if you're a modal structuralist, you'll say, well, if you've got coherent axioms, then that picks out a mathematical theory as the things that follow from those axioms. And fictionists will say, if you've got coherent axioms, that picks out a mathematical fiction as the things that follow from those axioms. So they all kind of agree that, in the sense that for something to count as a mathematical theory, it's just coherence of axioms is enough, right? But they kind of disagree over the ontology. But that might not be a massive disagreement. So where were we? So you said that Resnick's structuralism, he's thinking of it in terms of not necessarily involving objects, and perhaps that makes it closer to a fictionalist picture. I guess I want to say I'd be on board with that, obviously. The more allies, the better. although it's a little bit slippery because if you can be a structuralist who says, well, there aren't really mathematical objects, but there are these structures, right? And that still seems to involve some kind of Platonist commitment. So I'd want to hear more about what's really involved in that claim.
Right. I'm not exactly sure what he would say about that, but I do know that, at least from that paper, I think from 2018, something like that, he says something like, he still calls himself a realist, but about mathematical objects. But insofar as his, and this is an evolution from some of his earlier structuralist views, insofar as his structuralism is concerned, that view is silent on whether there are mathematical objects. But but then the structure is like, well, is that a thing itself, or could that be given a kind of nominalist friendly reading? Then maybe we are.
Yeah, but I mean, I think we've kind of seen with the thin thick distinction and the idea you could be a realist but think of mathematical objects as thin. That some of these questions about whether there are objects of a particular sort, they're slippery, right? So you might say, okay, well, look, I'm going to be a realist and say there are objects, but not in the kind of scary Platonist way that I'm not Gödel, right? not those heavyweight ways that people have thought about fictionalism. So, have thought about Platonism. So yeah, there is some slipperiness there in terms of what we're committing to when we talk about these objects as existing. But I've become increasingly interested in Putnam's claim that when he gave, so Putnam is well known in philosophy of math circles for the Quine-Putnam indispensability argument for Platonism, right? But Putnam himself claimed not to have been a Platonist and claimed that his argument was never intended as an argument for Platonism. He's got a kind of grumpy paper from about 2006 where he complains that everyone's read him the wrong way and he wasn't arguing for Platonism and so on and so on. And a little while back, I had a research project on maths and ethics, so I got to read lots of Putnam's ethical writing. And really interestingly, if you start reading Putnam on ethics, he talks an awful lot about philosophy of maths there, and he's much clearer there than he is in the standard things that people read about of Putnam on philosophy of mathematics. He's much clearer in his ethical writings that he's not a Platonist, right? So he gives a kind of makes no difference argument against Platonism. He says, if numbers existed, they wouldn't make it the slightest bit of difference to what we'd see in the physical world. So there's no reason to posit that they do exist and so on. Exist in the Platonic sense. And yet he says that he's a kind of realist and his indispensability argument is an argument for realism. So I've become kind of interested in what that could possibly mean and how you could be a realist in mathematics without being a Platonist. Just in terms of Resnick wanting to say he's a realist, right? I wonder if he's thinking along those lines, that there's something more to the idea of realism in mathematics than the existence of the objects. So Putnam, well, everyone likes to cite the so-called Chrysal's dictum, right? That what's at issue is not the existence of mathematical objects, but the objectivity of mathematical truth, and trying to work out in what sense mathematics could be objective. That gives you a kind of realism that's distinct from the fictionalism that Putnam claims to be rejecting is kind of a really interesting question, I think.
Right. Yeah, that remark there from Putnam, and I think you've made a similar remark. And last year I talked to Mark Balaguer on his book Metaphysics Offers You an Illusion, and he had a kind of similar illustration. Like I sometimes think of it sometimes like this, like suppose there existed the plenitudinous realm of Platonist abstract objects, but only every other day, right? Only every other day.
Yeah, right.
So whatever claims and theories, mathematical and scientific, whatever, that made, reference to things of that sort, they'd only be true every other day, on the on days. But like, there's not going to be any detectable difference to us, and our theories and claims and discourse for the usual purposes are going to be just as good, right? Can it be strictly speaking false, maybe? But I mean, do you think this is a good illustration? Do you think it helps maybe soften the blow of giving up on the strict truth of the various mathematical and scientific theories?
So I like that kind of argument, and I really have to think my way into what might be wrong with it, because if you start out as a kind of hardcore Platonist, of course, you're going to be very skeptical of that even making sense, right? Suppose the numbers exist one day and not the next. For starters, you think they're necessary existence, right? So them popping in and out of existence isn't going to make, you're going to find it hard to make sense of that. So some Platonists will question the sense of it. I think so, particularly Platonists who put a lot of focus on indispensability arguments and indispensability arguments as reasons for being Platonists. Some of them have resisted that argument by saying, actually, the numbers are so intertwined into the physical world that if the numbers popped out of existence, we would see a big difference. Right, and I find that kind of hard to make sense of, because they're meant to be acausal, right? But so it would certainly be the case that if the numbers popped out of existence one day and popped into existence the next day, our theories would go from being true to false to true to false, but not in a way that we'd expect to see that, right? And so because they're acausal, I'm inclined to want to say, well, that difference between having a true theory one day and a false theory the next day is not something that's going to make any difference to the success of our theories in the world. And that kind of just shows that the existence of mathematical objects or otherwise is not required for our theories to be successful. So it's a kind of anti-no miracles argument, if you like, because the no miracles argument says, well, how could our theories be successful if they weren't true? And the anti-no miracles argument says, well, if we are talking about them being true in what they say about the mathematical objects, actually, we wouldn't expect them to be any less successful even if there were no mathematical objects, right? So I do find it hard to think my way into the Platonist picture, where the Platonist says, well, look, if there were no numbers, things would be very different in the physical world, given that they're meant to be acausal. I suppose my best effort at trying to understand the Platonist worry there is to think, well, if you're a Platonist, you think that Hume's principle is true, right? So the number of F's is equal to the number of G's if and only if the F's and G's are equinumerous. If that's true, and that's part of your picture of what the numbers are like, that's true, presumably, if there's no number of F's and no number of G's because there's no numbers, then there couldn't be facts about equinumerosities either. Right? So if there were no numbers, there'd be no equinumerosity facts, and then the world would be very different, right? Because it looks like for the F's and G's, for these fingers are equinumerous to these fingers, that fact just looks like it is the case. Now, if you buy Hume's principle and think that whenever that's the case, the number 2 exists, then if the number 2 didn't exist, then there couldn't be equinumerosity facts in the world, and that would be a very different world. So I think that way of worrying about those makes no difference arguments perhaps makes best sense if you've got the kind of thin picture of mathematical objects in the first place, right? So on the thin picture, there's nothing more to there being a number 2 than there being these various equinumerosity facts, right? And so when we start thinking, okay, suppose there wasn't a number 2, that just is supposing that there aren't these equinumerosity facts anymore, and that's supposing the world to be very, very different. If you have a more hefty Plato's heaven kind of picture of mathematical objects, where Hume's principle is true of the numbers, but the numbers, the existence of numbers is kind of they just exist in their own right anyway, perhaps. Then in that case, I think it's harder to motivate the thought that if someone just wiped out the numbers, then the equnumerosity facts would be gone too. Right? But perhaps if you have a thin objects picture, there's a way of resisting those kind of make no difference worries.
Yeah, no, that's actually how I like the way you put that. I mean, I was going to bring this up. Like, someone could have the view that although acausal, these Platonic abstract objects, there's some sort of counterfactual dependence for some reason between what the world is like and whether these objects exist. Like, I don't know how this would work, but as you say, like, maybe they could just say, like, well, if there weren't these objects, then there couldn't even be like multiple trees or like particles, because that would require that there's this.
Right, exactly. Yeah. So if you think that the existence of trees, multiple trees, implies the existence of objects and the existence of numbers, the number of trees, which you would think if you're a thin objects picture, if you buy that thin objects picture, then it's going to be the case that if there weren't numbers, there wouldn't be trees as well, right? It sounds strange, but because it's just you're just turning your.
But people might want to say that it's not just for the thin objects picture. Like, there's a consequence for like.
Right. So it's a thicker picture. Yeah. So. Yeah, I think that's right. I just think there's much less strong reason for thinking that it could be the existence of objects in a thicker sense could be an implication of there being two trees, right? If it's not just if the facts about the numbers are not just in some way recarvings or dependent on rephrasing claims like there are two trees, so if they don't just pop up in that kind of thin way that Linnebaugh talks about, then I just think it's a lot harder to defend that kind of implication picture, right? So fictionalists like myself don't believe Hume's principle, right? I don't believe that the number of F's is equal to the number of G's, if and only if the F's and G's are equinumerous. What I do believe is if there were numbers, then that would be true of them. The number of F's would be equal to the number of G's, if and only if the F's and G's are equinumerous. But I just don't think that the existence of these objects' numbers could fall out of there being these facts about equinumerosities. So unless the thin reading, I'm kind of sympathetic to thinking, well, maybe if we're careful that we only mean existence in that very thin sense, that that's just what I mean by there being a number two, and so on. As I say, I've got some skepticism about. Well, at the very least, I think it's misleading, right? To say that gives us the existence of things. So, yeah. But yeah, I might give you the thin reading, but I think if your reading exists in any kind of heavyweight way, then that looks. Then it's suspicious, exactly. I'm going to look askance at that. I mean, these are kind of old worries of George Boulos, right? About logicism, right? That logic's not meant to give you an ontology. You're meant to be able to have an empty domain, right? And yet, if you buy Hume's principle as being a logical truth, then you can't ever have an empty domain, because you're always going to, from even out of zero objects, you're going to be able to get the number zero and, and the number one and the number two and so on, effectively. So I'm suspicious that we should, well, I'm wary of accepting those kinds of inferences as a matter of logic.
Yeah,
as opposed to a metaphysical matter. And then you might say, okay, well, if it's a metaphysical question that tells us that when you've got two things, there is a number, the number two, then it looks like it's logically coherent for me to say, well, even if there wasn't a number two, you could still have two things. Right? Maybe that's metaphysically impossible, but it's not logically impossible.
Right. Yeah, because in that empty domain thing, I mean, that's actually a worry just in logic elsewhere, because I don't want to bring this up really, but like, I don't know, you have people like Timothy Williamson who are necessitous, and it's like, well, our logic already has a fixed domain or something like that.
Right.
But even if you otherwise had an empty domain, it's like, well, okay, you can have the cardinality of the empty set and so on. Maybe you can, well, there's numbers in that sense, maybe.
Yeah. So that's the thing. If you allow yourself these techniques, you can quickly ratchet up to suddenly having transfinitely many things, right? So you can do set theory, give yourself the empty set and a few more axioms, and you've got transfinitely many objects, even if you started with no non-mathematical things, no physical things, right?
Right, and you mentioned that stuff on the no miracles argument, and of course you had a paper discussing some of that stuff, because like, I mean, one of the main points there was that, look, if our scientific theories are committing to mathematical objects in the kind of robust sense, at least, then our scientific realism, our arguments for scientific realism have to be, would have to establish also that there are those mathematical objects. And there's a worry that like some such arguments aren't really good to that effect, in particular the no miracles argument.
Yeah. No, absolutely. So I think scientific realists need to be a little bit careful sometimes about how they state their position and how they argue for it, because typically the arguments are constructed as arguments against people who are anti-realists about unobservable, say you're Van Frassen, right? So you're constructing your argument to try and convince someone to believe in electrons who is happy to believe in observable stuff. And you say, okay, well, look, it would be miraculous if our theories about electrons was successful in predicting the stream in the cloud chamber, or what's going to happen when I do this experiment. So it'd be miraculous if those theories were predictably successful if they hadn't got things right about electrons. And I think that's right. I think, it would be miraculous if the theories were successful if they weren't getting things roughly right about these unobservable physical objects. But the way those arguments are typically put is in terms of truth, right? So they say, look, it'd be miraculous if our theories were successful if they weren't true. And the truth of our theories, of course, requires, given that they're talking about mathematical objects as well as physical objects and real numbers that represent the masses of objects and so on. The truth of our theories requires the existence of mathematical objects too. And it's much less clear that that's a good argument when we think about, well, what we've just been talking about. What happens if we imagine there are no mathematical objects? Probably isn't going to make any difference to our theories being successful. So it doesn't look like on that kind of, if we accept that thought experiment of imagining all the mathematical objects popping out of existence, let's say, or coming in and out of existence one day after the next, it doesn't look like that's going to make any difference to our theories being successful. So we should be very worried about arguments for scientific realism that claim to be arguments for the truth of our theories, and say that the success of those theories would be miraculous if they weren't true. So I think it's kind of better to look at where those arguments work and where they don't work in relation to kinds of objects. So in a way, the mathematical fictionalist is a kind of, if scientific realism is the idea that our scientific theories are true or approximately true, if you're a mathematical fictionalist, then you've got two options. One is to dispense with maths in your scientific theories and show that you can do science without maths, which is the approach that Hartree Field takes. Or the other option is the lazy approach that I take, which is to say, well, no, I'm going to carry on using my maths in my scientific theories, but I'm not going to believe that those theories are true anymore. I'm going to believe that they're getting things right about the concrete stuff or the non-mathematical stuff, but not that they're right in their mathematical parts. And the challenge for that kind of fictionalist is really to distinguish themselves from constructive empiricists. So I draw the line not between observables and unobservables, but between physical and not physical, physical and mathematical objects, if you like. So I'm happy to believe in all of the unobservable physical objects, but not the unobservable mathematical objects. But why aren't I drawing the line where Van Frassen draws the line at the observable and unobservable divide? And one of the challenges is to say, well, why can you be realist to the extent that you are about scientific theories if you're not going to buy the mathematical bits? And I think if you look at that no miracles argument and think of it in terms of a makes no difference argument, so I think I called that earlier the anti-no miracles argument, if you like. Right? The makes no difference argument works very well for mathematical objects, right? At least if you buy some of the stuff we bought about their metaphysical independence and so on. Whether there's a number two isn't going to make any difference to me holding up two fingers, it's not going to make any difference to my being able to use the mathematics in our scientific theories. But if we try and give a makes no difference argument for electrons, it's much harder to motivate, right? So suppose all the electrons in the world existed one day, popped out of existence the next, existed the next day, popped out of to use your example. That's going to be definitely a wildly different world, right? We'd expect to see very different things if electrons popped in and out of existence that we wouldn't see if mathematical objects popped in and out of existence. So the kind of makes no difference argument helps to draw that kind of line between the mathematical and the physical causal entities in our scientific theories.
Yeah. Good. I was wondering, because someone could reply in the following sort of way, which is to say, we have to be a little more careful in this makes no difference example in the case of electrons. Say, it's maybe we don't just want to compare like there being electrons versus like there not being electrons, but it's there being electrons versus say there being something else that results in empirically equivalent observations, right? Because of indeterminacy and so on. And that would make no difference, suppose, as far as so, I mean, what do you think about that as a...
So then I think we need to look at the form of our scientific theories. So in our scientific theories that talk about electrons, they give them a lot of causal roles and so on, and a lot of phenomena are explained by them being caused by electrons and so on and so on. I think a theory that said things are as if there are electrons but there aren't would be a much less attractive looking theory, right? Because it wouldn't have the same kind of explanations of phenomena. It wouldn't have the unity of our theories as they actually are. So it would be a kind of grand conspiracy theory of, that all the observable stuff colludes in such a way as to behave as if there are electrons, but there really aren't. There's something else going on. I think that's a less attractive looking theory in terms of the virtues. And so the challenge then for the fictionist is to say, okay, well, what you're saying about numbers in a way is kind of similar, right? You're saying there's the realist theory that says there are these numbers and they're related to physical objects in this kind of way and so on. And then there's the conspiracy theory that says the physical objects are the way they would have to be to make the mathematical theory true. And so the challenge is, well, why expect the conspiracy theory to be true? Isn't that a less plausible explanation of what's going on than an explanation that says, well, there are these mathematical objects and things are related the way our theory says they are? So I guess the question is, why don't I think why don't I think that theory is a less attractive one? So the theory that says that so we've got one theory that says our scientific theories are true, and the other theory that says they're nominalistically adequate, i.e. they get things right about the concrete stuff. I guess one way of thinking why that the second of those theories is not a conspiracy theory or is not an unattractive theory is to think in terms of what mathematical objects are doing in our theories. So a lot of the use of mathematics is to represent how things are with concrete stuff. So when I use real numbers to measure temperature, for example, what we've got is there's these differences in temperature, and I can represent those differences in the concrete world with the mathematical stuff. What I want to say is, well, look, that those kind of representational uses of mathematics actually would work equally well whether or not there are mathematical objects, right? So if we start by saying, well, let's imagine there are these real numbers that have these properties and so on, or on the other hand say there are these real numbers that have these properties and so on. Either way, you can once you've made that starting point, you can use those objects, real or imagined, to represent temperature differences and so on. So I think that if mathematics is playing that kind of representational role in our scientific theories, then it's not that kind of role. It's not surprising that's a role that could be played regardless of whether the objects exist or don't exist. And that's very different from the role played by our story about electrons in our theories, right? So given that electrons are given this kind of causal role in our theories, it's really it would be really surprising if the physical world behaved as if there were electrons, even if there weren't any. Because they behave as if things happen that were caused by electrons that were caused by something completely different. On the other hand, it's not surprising that temperature scales behave the way they do in the physical world, because our mathematical theories our use of mathematics in our theories isn't making the temperature scales behave the way they do. It's just indexing features that are there in the physical world anyway. So it seems to me less of a stretch to say that the physical world could behave just exactly as if these mathematically stated scientific theories are true, regardless of whether there were any mathematical objects, if that makes sense. Because we're getting close to time, but I should just bring back one rejoinder to this, which is the question. So I've there rested very heavily on the thought that mathematics is playing a representational role in science, right? It's allowing us to say things about the concrete stuff. Platonists will respond to that by saying, well, actually, that's not the only role mathematics plays. Mathematics plays an explanatory role as well in our scientific theories. And if mathematics is playing an explanatory role, if I say, so there's the famous example of the periodical cicadas or cicadas, depending on whether you're speaking American English or British English. I call them cicadas because I heard of, because they're American insects, but these insects are really interesting. They have these cyclical life cycles. So you may or may not have come across these before, so I don't know how quickly to go through them, but they're these North American insects, and they only appear every so often, so they have these kind of long life cycles. And in the warmer southern states, they appear every 13 years, and in the cooler northern states, they appear every 17 years. And we ask, okay, why do they have the life cycles they do? And the answer is because 13 and 17 are prime numbers. And it looks like, so it's optimal to have a prime number length life cycle if you're trying to avoid other cyclical creatures, right? Because your cycle's going to over. If you chose 16 years rather than 17 years, you'd overlap with the 2 and the 4 and the 8 cycles. But if you choose 17, you're only going to overlap every 34 years with the 2 cycle and so on. So prime number length cycles are optimal, and so the explanation of why these creatures appear that many years is because 13 and 17 are prime numbers. And there it looks like maths is doing more than just representing physical facts. It looks like the mathematics is explaining things, and that makes it look more like, it's not causal as such, but it's more, that kind of role is more like the role I was saying that things like electrons have, right? If there weren't electrons, we wouldn't expect to see the track in the cloud chamber. If there weren't numbers, then we wouldn't expect to see these life cycles, perhaps you might put it that way. I'm not convinced by that argument. I do think mathematics plays an explanatory role, but I don't think the mathematical objects are really doing that. So what we have there is a kind of structural explanation. We're saying, so in mathematics, we say, okay, well, what would be true if there are numbers in any natural number system? These theorems would be true, and so on. And then we say, okay, well, the sequence of years in which the cicadas are appearing is an example of an initial segment of a natural number system, and so the mathematical theorem is going to apply there. So I think it is a mathematical explanation, but it's not one that involves mathematical objects. So that very quickly is my quick answer to that kind of worry. So the headline really is, for the fictionalist, is any use that we are making of mathematics in science, we can understand equally well from a perspective that says there aren't really any, or for all we know, there aren't any mathematical objects, and we're just working out what would be true were there any objects of this sort.
Yeah. So I was wondering, what do you think about this attitude here about the explanations here? Like, what if the nominalist can make use of these mathematical explanations that the realist wants to use, right? Maybe. Like reference to prime numbers and so on. Even though by the nominalist or fictionalist own lights, the claims are not, strictly speaking, all true. It might just be still perfectly fine explanation. It's not required that explanation everything said or reduced in explanation is true. Because and then we can, harkening back to the illustration before, like, okay, this explanation might be strictly true on one day and then not the next day, but it's more or less just, for all intents and purposes, it's just as good if an explanation is on any day. Like, does that make sense?
Yeah, I think that's right. But bear in mind the cost of that, which is that taken literally, then it means you're giving up on inference to the best explanation, because inference to the best explanation says whatever the best explanation you have is, you should take that to be true, right? And I'm willing to give up on that. What I replace that with in my book, I can't remember quite what I called it. I think it's something like accessibility of the best explanation. So what you need to do is make sure that you're the best, whatever the best explanation is you have of phenomena, it has to remain accessible to you given your picture of what objects there are. So I think causal explanations are not accessible to, they don't, all their explanatory worth disappears if you say, that track in the cloud table was caused by an electron, and I don't believe in electrons, right? Then you've not got an explanation anymore. I would say Van Prassen, of course, disagrees, but I would say that. If I want to say the cicada periods of the length they are because 13 and 17 are prime numbers, but by the way, I don't believe in numbers, I have to explain why that explanation is accessible to me, even if I don't believe in the numbers. And that's what I try and do with the kind of structural explanation story. But if I'm going to use that explanation, I have to say something about how that explanation can work if there aren't really any numbers. It's not enough for me to just say, yeah, I believe the explanation, but I don't believe in numbers, and stop there. Right? I have to explain why. I have to give an account of why it still works as an explanation, which involves saying something about. In my case, it involves saying something about how structural explanation works in mathematics and science.
Yeah, fair enough. I think that's right. Although maybe there's other ways to go besides just the structural stuff. But yeah, So I mean, I could talk about this all day, but I don't want to keep you too long. So I'd like to wrap up with a kind of general meta philosophical question, and that's like, I mean, what do you think is the value of philosophy, and in particular, maybe some of this stuff in philosophy of mathematics and science?
I think there's immense value to the individual, and then I'm not sure. Hopefully, I can try and explain some value to the world from it too. So the way I see philosophy is, for me personally, it's about getting my beliefs in order. Right. So I don't think necessarily philosophy can help us come to a consensus about what we ought to believe collectively. Right? There will always be disagreements because people will disagree over premises and so on. But what I think we can do, each of us individually, is do our best to come to a kind of coherent worldview that kind of fits together. And so, you and I may not share some commitments, and there may be some things that we're just going to never come to agreement on. Maybe you're a Platonist and I'm a fictionist, and we just can't come to agreement on that. But what we can do is try our best to individually to make our own belief sets hang together. And I take it that a lot of what I'm doing when I'm doing philosophy is trying to work out, get my beliefs in order, which is why I ended up doing some stuff on metaethics, was because I thought, hold on, can I be a moral realist and a mathematical fictionist at the same time? Does that make sense? How do I work it out? So even though I think philosophy doesn't, so people worry about philosophy, right? That we never agree or come to conclusions or say, okay, that's that, we've solved that problem now, move on. People worry that, maybe it's a waste of our time. But what we are able to do, I think, is work out what counts as coherent packages of belief. And make sense of that. And I think that's a valuable activity in its own right, in terms of getting our own beliefs and ideas in order. In terms of its value outside of the individual, I guess it does matter to think clearly about things. I mean, it doesn't really matter to most people, even to most mathematicians, that we know the answer as to whether there are numbers. Right? It doesn't really matter. I want to know because I want to know what to believe, but that doesn't really matter. But working that process of working out, if I believe this, do I need to believe that? Do I need to believe this? Hold on, this thing follows that I'm not happy with. What do I need to change? Those processes actually matter massively to all of us all the time, right? Because that's what we need to get around in the world, is to work out, and understand what we're committing ourselves to, and whether we really want to be committed to those things, and if not, what do we need to change? So I think philosophy in that sense is immensely practical, right? Because it's all about trying to be coherent and work out what we ought to believe. And so to do it in the kind of highly abstract philosophy of maths end is kind of practicing those skills it's like working out in the gym all the time, right? In a way, you're doing it at a kind of perhaps a self-indulgent extreme end, but the things that you're getting from that, that clear thinking and understanding how things hang together, is something that everyone needs. So occasional gym visits for everyone are probably good.
Very good, very good. All right, yeah, I like that way of putting it. Yeah, so thanks. I guess I'll draw the questions to an end there. But thanks so much for coming on, Professor Leng, and taking my questions and providing your very thoughtful responses, and for writing all the stuff that I've had to look at.
Well, thanks very much for your time and for your interest. It's been really nice to discuss, and I'll look forward to hearing more of your. You seem to have massive numbers of these podcasts, so I'm gonna go and discover the back catalogue now. So, anyway, thanks very much. Really enjoyed it.